Alright, so one of the first things that we're going to talk about right now is just the basic concept of climactic changes. Now, we know this, that throughout all of the years, that this little world's been in existence, we've cycled through ice ages and warm trends and cold trends and stuff like that. One of the first things we're going to talk about is the ice age concept. So as we know, when we talk about Ice Age, we know we're looking at poor old Sid here. So what really happened in the Ice Age? Talking about the Ice Ages, we talked about an average temperature decrease of about 5 degrees Celsius. Now that doesn't sound like a lot, but we looked at earlier, we were talking about some average temperatures and such in our neck of the woods, and we were looking at an average high temperature of about 80 degrees and then an average low temperature of about 50 degrees. But now we shift that down, so if we look at that, I mean, that's 9 degrees Fahrenheit that we're shifting everything down. So, if your average temperature in January is 40 degrees, then that means that most likely you're going to never get above freezing. Okay, just an example, So you could go December, January, February, March. You could probably go 4 straight months and never see a temperature above freezing in a large portion of the United States. So that being said, that's why it'll allow that snow to accumulate, and it makes it very hard for it to melt and disappear. But now, as we go through this, the most recent ice age it ended, key words here, ended about 10,000 years ago. Now, that's not saying that's when it started or anything else. But now, a couple of things as far as we're concerned with here in West Virginia is that it moved as far south as Indiana and Ohio. So let's see if we can find us a couple of good images here and take a look at some maps and stuff that show us where this ice age occurred. Okay, so what we're looking at here is some of the evidence that we saw of the glacial formation. And just remember, it ended roughly 10 to 15,000 years ago, but it started about 1.5 million years ago is when this started, okay? 1.5 million years ago is when it started. Now, a couple of things is we've got to think about this. As more of the ground got covered with snow and such, we had a reflective property. It's called albedo. We talked about that when we talked about some of the planets in our solar system a long time ago. So we're going to take a look at a couple other things now, and we're going to look at the short-term climactic changes, which we normally call these seasons, and we also have some things like El Nino and La Nina that we're going to discuss, and a couple of other properties, okay? So when we get there, we'll talk about that in just a second. Okay, so when we look at seasons and such, now that's directly related to the amount of direct sunlight that we see. Now, if you'll notice that when we look at the picture on the right here, okay? Now this picture here, you'll notice how all of the rays seem to be hitting the surface at about the surface of my apologies. The axis is not tilted, it's more of a vertical shape, so it's directly right on the equator. So this would be our spring and our fall, okay? Now that's when we have what's called the equinox. So the sunlight is evenly distributed from the North Pole to the South Pole. However, if we look at the image on the left, and we take a look at it, and if we look at it, we'll notice that it seems that the majority of the sunlight is striking the southern hemisphere, which would mean that it is the summertime for them and the wintertime for us. So the amount of direct energy from the sun that we receive over the given period of time really affects our season. So we know this in North America, when it's summertime, it's warmer. When it's wintertime, it's colder. And that's directly related to the amount of solar energy that we receive during those periods of time. So now, when the North Pole points away from the sun, it's our winter. When the North Pole points towards the sun, that's our summer. When the North Pole is directly vertical, that is spring and fall. Now we're going to take a look at a couple of things now about El Nino. So let's get ready to take a look at those. When we're looking at this is our normal conditions. We'll notice that we see that the cold water from the Antarctic moves up the coast of South America, and it has a tendency to move across the Pacific and warm up. And so you have the water currents and the trade winds kind of going together, and you'll notice that the trade winds are fairly strong. Okay, please remember the length of the arrow and such indicates the strength. Now, and that driven by the so what we currently see is that this high pressure system has a tendency to move cool, dry climate along the northwestern part of Australia. Now, however, occasionally for reasons we really don't understand, the high pressure system and the trade winds have a tendency to weaken drastically, which allows us warm water from the Pacific to surge eastwards along the South American coast. Now, this is what we see here. So this is where we have a change. This sudden presence of warm water heats up the air near the surface of the water, and this convection current strengthens, and the normally cool and dry northwestern coast of South America becomes much warmer and wetter. So we see a tremendous rise in temperature, and we see a lot more violent storms in the California and the Gulf Coast. Now, this stormy weather areas farther east are normally dry, and drought conditions to areas that are normally wet. So we got more of a reverse of what our normal standard our systems is. And once again, sometimes we have something called a La Nina. Now, this is when the coast of South America becomes unusually cold and chilly, and that conditions are called a La Nina. Now, when we look at the next of the things we're going to look at is the fact that we have a sun, and the sun generates radiation energy and such, and we have something called solar spot activity. So we have some information going on. So we're going to get a bunch of it out to us here. Now, what we're going to talk about now is the fact that we have a Maunder minimum. That's a period of low sunspot activity, or a low energy output from the sun. So when we discuss this, we notice that when we have a higher energy output from the sun, a high sunspot activity, the average temperature of the oceans has a tendency to be slightly higher. Now, when we see a low cycle, we notice that the temperatures are slightly lower. A couple of other things that make a difference for us, as far as the Earth and such, as far as the sun, we're going to notice that the Earth has a couple of other factors. The shape of the Earth's elliptic orbit appears to change. It becomes more elliptical, then more circular. So what we're looking at is this. Let's put a little map out here. So let's pick our sun here. So we'll draw our sun. Okay. Now let's take a look at our Earth solar system. Now we know this, that the sun is at one focus of the ellipse, and there's an imaginary point here. That's our second focus of our ellipse, and the Earth's pattern will be like this. Okay, so when we see that our standard Earth's elliptical orbit. So we'll see in each year we'll see ourselves swing quite a bit as the distance away from the Earth, and we'll be out there quite a bit. Now, when we look at this, if the Earth's orbit becomes more circular, we're going to be closer to the Earth a lot more. So that's going to affect our definite temperature. So if the Earth's orbit becomes more circular, we're going to notice that the temperature on the Earth has a greater consistency. It's going to stay the same throughout the year as it is. However, when it's more elliptical, we're going to see if it's in this location here, it's going to be warmer in this location of the elliptical orbit and colder in this location of the elliptical orbit, which is the red circle. Now, that being said, we've also got a bit of difference in our wonderful globe here. When we normally look at our tilt of the Earth, it's normally tilted at something called a 23.5 degree tilt. So if we drew a vertical line here, that angle between those two is about 23.5 degrees. However, our tilt does change. So we have a wobble. We wobble, wobble, wobble back and forth. So what that means is if our wobble, if we get more vertical in our axis, we get more direct sunlight to the poles. So therefore, we're going to be slightly warmer all over the surface of the Earth. So that wobble works. And this wobble cycles over 26,000 years. So right now, so if we had a picture of the Earth and our axis was right here and we point at Polaris, it might wobble, 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 and then we might have it wobble, 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 and then the axis is going to point over here at the star named Vega. So when we look at that, it can rotate. So as it spins, it's kind of like the wibble wobbles, but they don't fall down. The toys from a long time ago. Now, the next in what we talk about changing the effects of our planet and such is the fact that we get something like a volcano erupts. So boom, super volcano goes off. Now, we put out a big cloud of dust. Now, this big cloud of dust serves a couple of purposes. If it covers the globe really big, so when we talk about it and we deal with it and we put it there, so that volcano erupts and it produces a cloud cover of ash and soot and such. So if we have sunlight coming out, sunlight trying to go through the clouds, it gets blocked. So basically we have shade all the way around the globe. Now, we know this, what's going to be, it's going to be cooler underneath the shade, right? Now, this global covering of this can really have a short-term effect, okay? 1991, we had an eruption in the Philippines that dropped the global temperature about a degree or two as far as global wide, because we put enough particulate matter up there just to try to block stuff. Now, you might want to take a couple of minutes or so and think about some of the other ones. There were some big ones that happened in the early 1900s. Okay?